welcome you all on our online lecture series on element of machine design subject. In last lecture, we have studied introduction about key, their use and different types of key. In this lecture, we are going to discuss design of Shanki and some numerical related to design. Now, before moving in details, we will see some basic of key. Here, this object is known as a shaft and this rectangular steel element is known as key, and this key is inserted on top section of shaft where we manufactured a groove which is called as keyway. Here you can see that the dimensions for key are, this is a thickness, this is a width, and this is the length of key, which is inserting in shaft in this way. This is a hub section, or we can say it as a boss section of pulley, and this element is a shaft over which we have manufactured one keyway, that is slot or groove where the key is mounted. And we know that the applications or the use of key. In this way, when we insert key, that time it is undergo in two different stresses. First one, while tightening the key over the shaft, due to the taper section, the compressive stresses are induced. When we insert that key in shaft and push from this side, that time the compressive stresses are developed inside the key, and force due to the torque transmitted by shaft. When the torque transmitted by shaft, that time the torque is transmitted through the key to the hub section, and due to that transmitted torque by shaft, this produce shearing or crushing stresses in a key, and both the shearing and crushing stresses are on this plane. Here this is a crushing or shearing plane, and this diagram we have to draw in examination when the question asks explain with the help of net sketch design procedure of square Shanki. And by using this diagram, we can able to determine different parameters for direct shear stress condition and crushing or compressive stress condition. Now we will move towards the first point, that is different parameters or different values that we are going to use in design procedure. The first point is capital T. It is means that torque to be transmitted by shaft, and the unit of torque is Newton into mm. That means torque is equal to force into perpendicular distance, and the perpendicular distance of shaft is nothing but a radius, or we can write a radius as d by 2 also. So the formula of torque becomes T is equal to F into R, or T is equal to F into d by 2. Both are correct formula for torque. Then the next one is a F. F is equal to tangential force acting on circumference of shaft. Next parameter is small d, that is diameter of shaft. Now you have to write all the parameters in your notebook also. Then next one is a L, that is length of key. W is equal to width of key, this is a small w, and small t is nothing but thickness of key. Here this is a key section, and this portion is known as W, that is width. This line indicating as length of key, and this is a thickness of key, and the half portion is inserted in shaft. This half portion is inserted in shaft and remaining is inserted in hub section, and the force F is applied from this side when the shaft rotates in clockwise direction, or we can say as in this direction also. So the stresses which are going to produce in key section, that resisting area is from this side or from this side, and we are going to take only one resisting area, so we will prefer this side resisting area, and the area becomes L into thickness or L into width section. Okay, we will see in details. Now the first consideration is key is designed in direct shear stress condition. In this condition, that is direct shear stress condition, here the force F is applied or developed in this direction, and we know that the direct shear stress formula is tau D is equal to D, it is for direct, and tau it is for shear stress, and we know that the formula is shear force divided by resisting area. We know that the area is this one, this hatching portion, because the force applied on same section, so we will use that area only, and the force is represented by capital letter F, where the resisting area is width multiplied by length. Now we know that force is find out by using torque formula. Here torque is equal to force into perpendicular distance, but we know we need only force, so cross multiply both the quantity. I will write here separately. T is equal to F into R, and F is equal to T divided by R. Okay, remember this formula for both the condition, or consider or write this formula as equation number 1, and put this equation in our main formula, that is tau D is equal to F divided by W into L. Instead of F we have to put T divided by R. Now I will put here, and the equation becomes tau D is equal to torque T divided by R divided by W into L. Now simplify this equation, and main equation we will get as T is equal to W into L into tau D into R. Okay, in some textbook or a reference book, instead of R they have used D by T, and we know that half of diameter is nothing but radius, so tau of D into D by 2. Both the formulae are correct one. Okay, here T it is torque, W width, L length, tau D that is direct shear stress, and R is nothing but radius. And by putting all the quantity, we have to calculate length and width of key section. Then the next condition is by considering crushing or compressive stress in key. For that purpose, I will write here sigma c, that is stresses, which one? That is compressive stresses. And we know that the formula for same is compressive force. This is compressive force divided by resisting area. Here the area is, now it is not only W by L, because only half a portion of that area is inserted in hub section. So only that section is having that crushing or compressive stresses. Here you can see that this portion, hatching portion, is in shaft, and the remaining portion, which is indicating by a red color, this portion is in hub section, and only that portion is having crushing stresses. Okay, so that we have to take only that area, that red section, and that area is not equal to W into L. Now for that purpose, what we have written this section or this length as a T, that is thickness of key, and the half portion is T by 2. Okay, so the area is equal to, I will write here T by 2, that is half section, and the total portion and the length of key, here I will write as a L, that is resisting area for crushing, and compressive is become L into T by 2. So put both the value, that is value of F and value of area, in this equation. What is the value of F? This one, equation number 1, and I will put here sigma C is equal to T divided by R into L multiply by small t by 2. Okay, now solve this equation, and the final equation in terms of T is equal to L into T by 2 into R into sigma C. Now we will write here sigma C first of all and R at the end, and we can write this equation as T is equal to L into T by 2 multiply by sigma C multiply by D by 2. Both the equations are correct one. Okay, this is second condition, that is key is under crushing or compressive stresses, and by using this formula we can able to determine thickness of key section. At the end of the screen you can find the numerical screen at right section. Click on that section, so you will get the numericals on design of key. Thank you.